So now here, we're going to look at whether or not there's horizontal asymptotes or oblique asymptotes. What's going to happen? Again, we always factor first to see if there's something that cancels, to see if there's a hole, and we'll see if there's a vertical asymptote. And then after that, we're going to see what group it belongs into, group 1, group 2, or group 3, and then what kind of asymptote is going to be. All right. So for this one, y equals x squared plus 6x minus 7. We can factor the top to x plus 7, x minus 1, and we have an x plus 2 on the bottom. So it does not have any holes. When we're going to go to graph this one, I'll start the graph. Then we're going to look at what we'll need to do to figure out the rest of it. And we'll start with our asymptote at x equals -2. Now, before we go further, let's go back and highlight some stuff. They have characteristic number 2. And 3. Okay? And they go through a lot of explanation here. You can summarize this completely by just the following. This is sort of the way, a one-step thing to figure out all of these asymptotes, because there's going to be 3 situations that can happen. Okay? I'm going to start with group 2 and 3, and then end with group 1, where we had the oblique asymptote. So for group 2 and 3, you had either one of these situations. Either the degrees were the same, or the degree was larger on the bottom. So sometimes if you had a situation where you had, 5x squared plus 3 over 2x squared plus x, if you have a situation where the highest degree is the same on the top and the bottom, then you just look at the terms with that highest degree, which would be your 5x squared and your 2x squared, and that's going to tell you you're going to have a horizontal asymptote, because that simplifies to 5 over 2. You would have a horizontal asymptote at 5 over 2. You might have a situation where there's a higher degree on the bottom. Say I have 5x plus 3 over 2x squared minus 5. The highest degree in this rational function is still the x squared. I have a term with a 2x squared on the bottom, but I have no x squareds on the top. And this is group 3. Group 3 was when the degree was bigger on the bottom. And the same thing, if I simplify 0 over 2, every time the degree is bigger on the bottom, you'll have an asymptote at y equals 0 for your horizontal asymptote. The second situation is group 1. In group 1, that's when you have a higher degree on top. So like what we have in our example right now, where it's x plus 3, x plus 1 over x minus 2. If you multiplied the top out, you'd have an x squared. The highest degree on the top is an x squared. You have no x squareds on the bottom. This is not possible to actually figure out. So you're going to find out, because it's not possible, we do not have any horizontal asymptotes. This will tell you you have no horizontal asymptotes. and it's telling you that you need to find an oblique asymptote. How do you find that oblique asymptote? You have to go back to your skills from Chapter 1, where we did synthetic division and long division. We're going to try to always do it with synthetic division, but if you get an expression that you can't divide using synthetic division, you're going to have to use long division. So this is the summary. When you look at the highest degree, you'll be able to tell whether it's group 1. Summary. This was group 1, where you had no horizontal asymptotes. You might have a whole or oblique asymptote. Group 2, where the degrees were the same, where once you simplify it, that's where your horizontal asymptote. Or group 3, where the degree is bigger on the bottom, then you'll have an asymptote at y equals 0. When you do have group 1 and you have an oblique asymptote, this is what's going to happen. Okay, this is a horizontal asymptote where they do it a way longer way, but this would be an example of a group 1, x squared over x plus 1. You can see that the highest power is an x squared. We have an x squared on the top, but none on the bottom, which is not possible, which is telling us you're going to have an oblique asymptote. What you do to find your oblique asymptote is you actually do the synthetic division. If I took x squared and divided by x plus 1, I have 1x squared, no x's, no constant. You do 1, 0, 0. You're dividing by x plus 1, so we put the opposite value here. Bring this number down. 1 times 1 is negative 1, add. Negative 1 times 1 is 1, add. And you get as an answer x minus 1, remainder 1. It doesn't matter what your remainder is. You can ignore that. The equation of your asymptote will just be whatever you get when you divide. And that'll be the equation of our diagonal asymptote. So now, we can go back to the question we were working on. That was sort of a summary. We can see in this situation that we have, we know that we're going to have a vertical asymptote at x equals minus 2. When we look at the highest degree, we have an x squared is the highest degree. We have one of those on top. We have none on the bottom. So this one is going to have no horizontal asymptotes. It will have an oblique asymptote. To find out what that oblique asymptote is, we're going to divide. Can you use synthetic division for this one? Yes. So we'll set it up. We've got 1, 6, 7, and we would be dividing by x plus 2, so we put negative 2 there. Bring down the 1, negative 2, add 4. It's negative 7? Add, and we get negative 15. And even if I had made that mistake of 7 or not negative 7, it's not going to matter in the end, because all that matters is x plus 4. You can ignore the remainder of negative 15. X plus 4 is your diagonal asymptote. That's just a line. It's easy to graph a line. 1, 2, 3, 4. 4 is your y-intercept. It has a slope of 1, up 1, over 1. And there you have your oblique asymptote. Now to graph this completely, you're going to go in and put as many points as you can. Since we factored the top, it's easy to find our x-intercepts. Can you see that minus 1 is going to be an x-intercept? Plus 1 is going to be an x-intercept. Thank you. You can see that plus 1 is going to be an x-intercept. And you can see that negative 7 is going to be an x-intercept. 1, 2, 3, 4, 5, 6, 7. x minus 2, our vertical asymptote, is going to determine what two sections we need to do our graph in. Do we have a point to the right of x minus 2? Yes, we have this plus 1. So now you can finish your graph, have it go towards the asymptotes like that. Do we have a point on the left side of our vertical asymptote? Yes, we do right here. So this part will go, whew, that's pretty bad. That doesn't look very smooth. I gotta redo that. Okay, how about, ugh. It's a little bit, it gets a little messy sometimes, but you have to have it curve towards your asymptote, go through that point. Can someone tell me what this point is? We know this one's at 1, 0, and this one's at negative 7, 0. What's our y-intercept going to be? Well, that's always when x is 0, but what's y? Close. Close to 3. How do you find a y-intercept? Make the x 0. Can you see that this would be 0, this would be 0, this would be 0? What do we got? Negative 7 over 2, or negative 3.5. So there's your y-intercept. For B, again, we're going to factor completely. It's the same question, just flipped, right? Nothing cancels out. So when we start with your vertical asymptotes. You're going to get a vertical asymptote at 1. That's not. And over here at negative 7. What's the highest degree in this whole question? The x squared. We have an x squared on the bottom. We have no x squareds on the top. What group is this? What's that?
2.
Group 3.
Oh, yeah. Group 2 is the same.
Group 2 is the same.
Got it.
Might go blip blip. Yeah, exactly like blip blip. But if we simplify this, this is the group that always has 1 at y equals 0. And now we're going to need points in each of the 3 sections. We're going to try and find, can you find your y-intercept? Can you see that your y-intercept when you put x is 0 is going to be negative 2 over 7? 0 comma negative 2 over 7. Because when you plug in 0 for x, those would all go away and you get 2 over negative 7. So now you have a point in this section from negative 7 to 1. So this part will look like that. It's a blah blah graph. Now we need points in the other sections. So plug in a value bigger than 1. Say 2. What happens when you plug in 2? You're going to get 4 on the top, 9 on the bottom. Two comma 4/9. Estimate. I plugged in 2 on the 2 plus 2 will be 4 on the top. On the bottom I'd have 2 plus 7 is 9. 2 minus 1 is 1. So I get 4/9. And then this one will look, it'll go towards the asymptotes like that. And a value less than negative 7, try negative 8. Can you see on the top you would get negative 6? And on the bottom you would get 9? Is that right? Or negative 9? What happens when you plug in -8? On the top you would get -6, right? -6 over 9? Ooh. I wonder. Okay. I'm going to check this middle section out. -6 over +9, you said? Okay. So that's going to be down here. It's going to look like this. I'm getting a feeling that our middle section might actually be different. It might be one of those nasty graphs that crosses an asymptote. I don't like those ones either. So I'm going to re-look at my middle section here. One thing to find out if your middle section does cross is if there will be an x-intercept. Is this fraction ever equal to 0? If we look at the fraction, is the numerator ever equal to 0? Yes. When does that happen? At -2. So if we have that point, -2, 0, which happens to be on our asymptote, if we do get a point that's on the asymptote, that'll mean that'll go up. I know it goes against everything we feel like we should do, crossing an asymptote, but that'll be the way that you can tell if it does cross the asymptote, is if you find out that there is an x-intercept, if your fraction is ever equal to 0. In this case, it is. So we get a point that is in our asymptote, and remember that a horizontal asymptote is mainly there to show what happens as x gets very, very big, or as x gets very, very big negative numbers. So it is possible that it crosses, and this one did. All right, the questions we can do for practice here are 6 and 7. Questions for number 1 were just 5, I think. Is that right? Yeah.